So the last little part of chapter 2 has to do with finding the equations of lines that are parallel or perpendicular to a given line. And we've already talked about what the relationships of slopes are. So if the slope of a line is a over b, then what is the slope of a parallel line going to be? A parallel line will have a slope that is the exact same, right? And what would be the slope of a perpendicular to this given line? The negative reciprocal. So flip your fraction, or change the sign of your slope. Okay, so if I gave you an equation, so if I said that you had 2x plus 3y is equal to 1, and I want you to find a parallel and perpendicular line, passing through the point negative 2, 3. Okay, so we want to find the equation of a line that passes through this given point that's one parallel to this, and then a second one that's perpendicular to it. So it's two separate equations. Okay, what you would do first is you would need to find your original slope. So how would we find the slope of this original equation? Solve for y. Okay, so all you need to do is solve your equation for y, and then that allows you to view the slope. The slope is going to be the coefficient of your x term. So if we solve for y right here, okay, we get 3y is equal to, we subtracted a 2x from both sides, and then divide by 3. So we find that our original slope is equal to the coefficient of x, negative 2/3. Okay, once we find our original slope, you can now identify the slope of your new line. Okay, so in this particular case, our new line is, let's do parallel first. What's the slope of a parallel line going to be? Bless you. Same thing, negative 2/3. Okay, and then our final step here is to solve the equation of a line given our slope and a point that passes through. And so we can either use point-slope form or slope-intercept form. Again, most of you are probably more comfortable with slope-intercept. So if we take our equation, y equals mx plus b, we substitute in our x and y coordinates. So here's our x and our y. And we use the slope that we just identified, negative 2/3. And we can find the y-intercept for our parallel line. So if we plug in a 3, a slope of negative 2/3, our x coordinate of negative 2, our b value, we can simplify what we have. Negative 2 times a negative 2 is a positive 4. Well, let's write 3 in terms of thirds. So 3 is how many thirds? 9. And so now when we isolate and solve for b, subtracting a 4/3 from both sides gives us 5/3 for b. And so the equation of our parallel line, again the two vertical bars represent parallel, is equal to, our slope was negative 2/3 x, and our b value, our y-intercept, is a positive 5/3. And so that would be the equation of a line that's parallel to this given line and passes through the point negative 2, 3. All right, when we look at this, we can do the same steps for coming back and finding the perpendicular. So here we identify the slope of our new line. The slope of our perpendicular is going to be what? 3/2, switch the sign. So here's our new slope. And so once again, just use y equals mx plus b. This time our x and our y's will stay the same, -2 and 3. Our new slope m is going to be 3/2 though, and we can find what the new b value is. So if we plug in a 3, 3/2, and a -2 plus b, and solve, we get here the 2's cancel. So -3 plus b is equal to 3. Add 3 to both sides to isolate our b value, and we get b is equal to 6. So the equation of the line that's perpendicular to the given line has a slope of 3/2 x and a y-intercept of 6. So here would be the equation of your perpendicular for that.